for 3D printing homes, they have it to the point where they're 3D printing entire neighborhoods. And I don't remember the name of one of the big home manufacturers is actually testing this out with an entire neighborhood right now, where they're 3D printing all the homes. And it's really cool. You can tell it's 3D printed because it is layer by layer by layer. You can see the concrete.
Right. I've seen the videos where they it's like a big almost like spout that just goes around on like a big old CNC machine, and it just kind of pastes another layer on, every round. That's right. Yeah. And then once that structure is built by the 3D printer, that's when they go in and they start putting in the windows, and they don't have to cut out holes for the windows and stuff because the 3D printer accounts for that, right? So it'll build the bottom layer, and they're building a little bit. Yeah, they're building it straight through. Yep. So, and then they'll put the drywall on the inside and stuff. And now it sounds like it would be like crap to have like these layers on the outside. But when you go and you look at these on the websites and stuff, they actually look really cool. Yeah, I really like the. Oh, sorry, Greg. Go ahead.
No, go ahead.
I was saying I really like the the layered look and the layered design, and also you don't have to worry about things like termites or insulation or all the things that come with a wood framed home, because you don't have to worry about any of the wood. That's right. Yes. And it's sealed really tight too, which is fantastic. It's insulated super well. Like it's a really, really good approach to building a home, and it's a cheap approach to building a home. So we save a shit ton of money when we do it as well, which means more affordable housing, which it might be the answer to our current housing crisis, which is coming in 3D printing homes. If we can go and 3D print a whole neighborhood in a week versus like a year of building one house, then we can change the housing market right now. Yeah, no, that's absolutely right. Yeah, I mean, I think there's a lot of benefits to 3D printing, and I think that we have been stuck for the past 100 years in the proper way to quote unquote build a house that is just completely antiquated and unnecessary to build a house with wood frames and bricks and plaster and molding, when there are much better, more modern materials that are out there that could reduce cost and increase efficiency. Yep. And it just may not look like what everyone is used to seeing a house look like. Yeah. And I mean, and this is just a modern day application. Like today we can do this, and then the other thing is we've got, now you're capable of putting a cheap, like $250 3D printer on your desk, and like, you can 3D print plastic screws and stuff that are actually pretty durable, and they work really well for just like basic repairs and things like that. Obviously you don't want to go build a deck with it, but it's really, giving the power to the people. Yeah,
it's crazy how easy it is now to get one. I remember back in 2014 when it was basically there wasn't really anything available on the market. There may have been one product, and it was like $1,000 or more. And most of what people were doing, like in the hobbyist community, were building their own just from parts and stuff. Well, obviously without 3D printed parts, but, building it from scratch so that they could at least get in on this early. And I say early, but this technology has been available since like the 80s when it was first created. We have a company that's been around since then, 3D printing. It's called 3D Systems. They were like, that's as far as back as it's gone. And it's so weird that it hasn't really been talked about much until it started getting more user-friendly and more widely available with like plastics and all that.
I did not know that. From the 80s,
That's interesting.
Yes, actually,
CNC machines have been around for quite a while, so like the idea has been there, but I think the biggest technological advancement with 3D printing has been the creation of the filament. Right. That's right. That's been the big thing, because the filament is a malleable material that can be, heated up and molded into whatever you want, and then it hardens into a complete sturdy solid. Don't get me started on resin filaments as well. That's a whole other ball game, right? Like now that we're getting into resin and it's becoming more efficient, like we're getting more detailed prints than we are with just melting plastics, Right. That's completely, I completely agree. And you also can now have multicolored filaments, and you can have filaments that are made out of
ones too. Exactly. Like really durable. Exactly. There's really flexible filaments. Like it's endless what you can build with this stuff today.
How long do you think it will be until car manufacturers, especially high-end car manufacturers, go to 3D printing carbon elements rather than, casting the carbon, or it's not casting, but, making the carbon pieces by hand versus 3D printing them? Right?
Oh, that's a great question. I don't really know. I don't know what car manufacturers
because I don't think carbon is. I don't think carbon is there yet.
It's
I don't
not
think
quite
carbon
there on
filaments
its
are.
own. You have to
Right.
mix it with other material. Yeah.
Right. But when we get to that point, I think that's going to be a really big advancement forward.
It really will, and even
it'll
more so for the
significantly
military.
reduce the cost of carbon. It'll significantly reduce the cost of carbon being added to vehicles for improved
That's right.
efficiency, which right now is a pure luxury thing because it's more seen from a performance aspect. But if you could 3D print and reduce that cost, then you'd be able to really see advantageous, profits coming in from carbon filament manufacturers. I mean, that's a whole new industry that just doesn't even exist yet.
Yeah, I mean, correct me if I'm wrong here, Rocket, but currently the auto manufacturing industry is just using carbon to reduce the weight of their vehicles to get better performance, whereas
That's
carbon
correct.
is super conductive. Like it can take in electricity like crazy, and it's extremely durable when built right with the right materials. So if you get like a proper carbon material that's extremely conductive, and maybe you can combine that with some sort of technology and put it into an electric car, now you've got the real benefits of carbon other than just weight.
Right. No, I completely agree. I will say though, carbon, in its current form, when you're dealing with composites, around carbon, they only bend in a specific way because of the way that they are made. And if they bend the wrong way, then they will break very, very easily. Right. If they bend the wrong way, they break really easy. And so that is something that, we will see in the future. If this, if you can 3D print carbon, parts, then I think that's going to be a big challenge, is the durability around something like that versus your traditional metal parts.
It's very durable. It's just brittle. Like it's
durable in the way that you want it to be, but if it is hit from a different angle, then it's very, very brittle and breaks really easy.
Yeah,
so,
it's a difficult material to work with.
Right.
But yeah, that's our 3D printing today. And as we move into the future, we're looking at military applications where we're 3D printing jets and tanks and things like that using metals, right? And alloys. Right. And then once we're at that point where we're 3D printing metals and alloys, that's when we get into the car manufacturers starting to 3D print their materials and things like that. And then we're reducing costs even more. And remember, the best way to reduce cost as a business is to come with some sort of industrial manufacturing plan, right? Like if you build something by hand, it's going to cost 10 times more. If you build something manufactured, then it's going to cost 10 times less because you can manufacture it much faster, right? So
that is also known as Wright's Law, which in layman's terms basically means, and I forget the exact definition, but basically the more times that you do something, the more efficient it becomes.
That's exactly
when it comes to manufacturing or to anything. The more times that you do it and the more people you have doing it, the faster that process will become.
But we eliminate the people in this process. Right. We're just 3D printing. And then that process becomes so efficient, it becomes extraordinarily cheap. Right?
Right.
And then we talk about space travel. And this is where we get the real benefits of 3D printing.
Right. My biggest benefit around 3D printing and space travel that I can see is the ability to 3D print and to basically make materials in space while you're in transit somewhere.
That's absolutely right.
Rather than
making materials you need, but even more so, let's say you're some sort of AI or you're some sort of like technological being. You're just going to 3D print more of yourself or more spaceships, right? To scatter more of the space and discover more space faster.
Right. That's exactly right. Because you go gather. I mean, like everyone, I think by now has played. What's that fucking game that we play?
Some RTS game, I'm assuming. Which one?
Yes, it's the one that's been in beta for like 5 years, and now you have
Planetary Annihilation.
No,
no, Rocket hasn't played that.
Satisfactory.
Satisfactory.
It's just like that.
Yes.
And so that's what I think of. That's
Yep.
what I think of, is that you will have ships that are completely autonomous, landing on planets, gathering resources, then building more resources
That's
to gather, or
right.
building more pieces to itself to gather more resources, and then shipping all of that back via
you've got
space elevators and all that crazy
an
shit.
automated society, pretty much. Not an automated infrastructure, an automated entire society. You've got agriculture, you've got machines, buildings, everything just totally automated and creating itself, doing everything, and it's expanding on its own. And this is the potential of 3D printers.
Not just inorganic material either. We're also talking organic as well.
That's right. That's a great point. Yeah.
Somebody back in 2004, the first 3D printed organ was transplanted in a kid with like a bum bladder. They were able to replace it back in 2004. It's still working today as of 2022. I couldn't find anything from this year to see if it's still going, but
that's
as
still
of right now,
that's...
it's still working. A functioning bladder. Obviously,
That's
it's not
incredible.
like a heart or something as it's a simple organ.
I was just
compared to
actually
the
speaking of a heart. I was just going to
but-
mention. I heard they 3D printed a heart. Have you guys heard about that?
I did hear about it, but I didn't hear anything past that they had printed it.
No, I don't think they did
know if they
anything with
actually
it.
It was
Yeah.
put it in.
basically
Okay.
just still like that's like alpha right there.
Yeah.
Basically just the proof of concept that it's still nowhere near ready for
3D
anything
printing
like
food,
that.
agriculture, right?
Yeah,
heard
I
about-
mean, I think that, that comes into a good question, not just around the, around like, say I want a steak, right? But we're talking about like printing an entire sandwich, right? Not just a single piece of
I'm thinking
material.
of just the meat, but yeah, you're right. Like
The meat as well. I think the meat
I
as
think you
well,
would
and
have
that's the first step.
That
But
goes back to the
eventually,
multiple filaments, right? Like right now we have multiple
Right.
colors.
What-
Now we have
I
a
could have a
biological
grain
filament
filament.
for the meat, another filament for the lettuce, and another filament for the bun. Like there
Yeah.
you go. There's
I
your
mean, and
sandwich.
how
How
many
do you-
tomatoes can you spit out a day? 3D printed tomatoes,
Oh,
slices
man,
can you
yeah.
spit out a day?
Yeah.
Would
Right?
you even have to worry about cross contamination at that point, since it's literally like just
It's
like
all tomato.
source? No, well, when you're switching
Well,
the
it depends on
filaments, like
the
that
filament,
from like the meat
right?
and then
Who
to the cheese and
manufactures
all that.
the filament? I would worry
Yeah,
about
I mean, like,
contaminants
there's-
if the filament, like who's handling the filament,
Right.
how's it being handled, all that stuff. Yeah.
Right. I'm assuming it would still have to be, maybe it's refrigerated. I don't know.
I would assume
and this
so.
comes
If it's an
into
organic
this comes
material,
into
I'm sure it's refrigerated. Yeah.
it'll be your 50% bug and 50% cricket.
Yeah, something like that.
50% meerkat, whatever
Yeah.
whatever combination of ground meat they choose that day. But yeah, I mean, but that also ties into our previous episode about growing cells, right? You could grow the cells, shove the cells into a filament, and then spit out a patty.
Yeah, it's really good that you're bringing up agriculture in this, though, Greg. Like, with the meat and everything, it's really important that we discuss this and as the future of 3D printing as well, because this has a huge impact, not just space travel and stuff. We got the burgers, the burgers
see-
with
but see, like,
15 filaments.
I go back to not just building the food itself, but building the architecture around producing the food, right? And
That's a
so
good
maybe if
point.
the food, maybe if you can't have like a grain filament, right, and I can't have a tomato filament for making a 3D printed burger, what I can have is the ability to build structures from an autonomous vehicle to, build greenhouses, right? I could 3D
That's a
print
good
greenhouses.
point. Yeah,
I could 3D print. I could have automated machinery come in and dig out waterways, and then I could 3D print concrete into those
man.
waterways to make sure that those stay there for an extended period of time.
You really
right?
could.
Like you could really build
a
the
whole
agriculture
farm in like a day
exactly. You just bring in all these 3D printing autonomous machines,
with
and they
AI,
just say,
right?
Yep.
It has AI, so it maps the area, it drives around, and it cuts the ground open where it needs to lay, make sure it's level, and then just 3D prints the concrete or whatever it needs to 3D print to build your structure.
Yep.
Oh man, wow.
And if
yeah.
something breaks down, like a part or something, you can just make another one instead of having to wait like weeks for a new part to come in.
you
from
have
the
little robots
manufacturer.
that just run out and fix it.
Yeah, basically like a little
yeah, I
pit
mean,
crew.
like once you like say that like it's the same thing as like any other handyman, but you have a handy robot, right, that just runs around
Yeah.
and fixes things
That's
that are
a-
broken, and
that's
it
a good
automatically
point.
detects it because the AI senses something's wrong. It senses
Sends
an
it a
anomaly.
message.
Yep,
No,
it
just
senses
send a
an-
message. Yeah. It's like,
Well,
hey,
but yeah, that's what I'm saying. Yeah, it just like there's
Yeah.
sensors everywhere built into all this, and then it detects an
Yeah.
anomaly, sends a message, the little robot comes out, fixes it, bada boom, bada bing, no humans involved. So
Yeah, you don't even know it broke that day, you know?
don't even
Robot
care
walks
because the
up,
robot's
3D
going to
prints
fix
the
it.
part, runs over there, fixes it, runs back, and you're just sipping your coffee.
Yep.
What could have been a
That's it.
detrimental event ends up being just like a log event. Oh,
That's
hey,
right.
part 31A broke at this time. Okay, cool.
Yeah. No, that's absolutely right. So, all right. Well,
Man.
what else you guys got? What else is going on with 3D printing?
Well, we could dive deeper into the military part of this. I think that's going to be quite interesting.
Yeah, I think that the military side of 3D printing is not even at its genesis yet. I mean,
No,
I
it's
think,
not. There's
and
concepts,
not even-
but it's
I
not
think
out yet. It is
even-
not
even-
close.
I'm going to go more specific than the military, and I'm going to go more to the clandestine operations of the government. Right.
Right.
I go back to thinking about the making of the faces in Mission Impossible. Right. You always all remember that
Yes.
machine.
Yeah.
But in a real practical application, that's possible today.
It's
just plastic.
It is. Yeah. It's
just
well,
rubbery plastic.
It's not plastic. It's silicone.
Silicone, yeah.
Yeah,
But
yeah.
like you could make something pretty close with 3D printing today if you
really
had
could.
enough time. If you had enough time and small enough filaments, you could make something.
With an
that
advanced
detailed.
3D printer, you definitely could. And they are using alloy 3D printers today. Like you can do it. You know, people
Yeah.
are 3D printing with alloys. It's not just plastics, but those are on like an industrial scale.
Right. I think though, we will get small, as with all technology, things start very big and they get smaller and smaller and smaller and more efficient. And eventually you'll just be able to, which we already have, I would say the basic 3D printer available in, home use today. And of course you can spend a lot more money to get something a little bit more advanced. But like you pointed out, Red, using alloys and having an alloy 3D printer, that's probably the next thing for a residential and for,
I think so.
a more advanced prosumer type use. But
Yeah.
going back to, the clandestine side of things, I just think about all the different applications. Like I need to print a key. I need to print a cell phone. I need to print, even if it doesn't work,
Right, I
the
just
list
bought
just
the
goes
new
on and
iPhone,
on and on.
and
I'm
you
a
don't have to-
spy in a
yeah.
foreign country. I need a passport. I need a driver's license. I need you know what I mean? Like,
Or
being
even
able
better,
to,
I'm a spy in a foreign country. I just need a weapon real quick. You know?
yeah, that's exactly right.
Whip it out. It's it's like a foldable 3D printer. You just whip it out, boom.
Which
3D print a
so
gun real
this
quick.
this
Or
brings
3D
us
print the
into
parts and you put it together. But yeah.
So this brings us into a very interesting part, which Vice actually did a really good documentary on 3D printed guns.
I watched that, and it's like the guns suck.
Well, the guns suck, but they still are guns.
They're
right?
still guns, and it is impressive.
And they're unregistered, right? They're not
But you
registered
fire
guns.
like 2 bullets, and then it
And
like
depending
blows
on
up.
your depending on your use case, it may only need to work once.
Right. That's
Yeah,
that's exactly
that's true.
right. And
Yeah.
so my point comes back to like, of course, this 3D printing guns thing has maybe been around like a decade, maybe a decade and a
Yeah.
half. How much longer until you can get through an entire mag on your first print, right? And it works right the first time because as printers get
maybe
more
like
and more
6 or 7
precise,
more years. Yeah.
as printers get more and more precise, then you're going to have less and less room or less and less margin of error, right?
That's right.
So-
Yeah. Because there's going to be a point where you don't have to sand them down and like
Right.
fix.
You'll
out
be
the
going
parts
away
and
from
stuff, yeah.
millimeters and you'll be going into nanometers, right? And
Yeah,
then when you get to
and
nanometers,
I don't think anybody's
things
used
become-
a resin. Has anybody used a resin printer to print these parts yet? I haven't
Now-
seen anybody
I
do
don't
that.
know.
Now, y'all were talking about using 3D printing metals. The closest thing to that we have right now that we could do in our own homes if we had 3D printers and the materials is electroplating it and just adding layers of
What's
metal
electroplating?
onto. It's basically a process of transferring thin layers of metallic atoms from one surface to the other. And in this case, it's being transferred onto the 3D print itself. The first time I've ever seen it used was actually by cosplayers who were 3D printing like Iron Man and Mandalorian helmets, and were using electroplating to coat them in metal and make them like hard shell.
So it creates
metal.
a metal coating. It doesn't
Basically.
create a metal structure. It creates a metal coating.
Yes, just the
'Cause
coating.
what you were describing
like
didn't
similar
make
to like
sense
gold
me,
plating.
but That makes
Yes,
sense.
that's what I meant. Sorry.
Okay.
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 So it's not an alloy structure. It's just a plating around it, which makes a lot more
Exactly.
sense with what you described.
Yeah.
Okay.
Yeah. Okay.
Exactly.
I know
It's
that
that's
they-
close
really
thing- That's
cool.
the closest thing that you would get to
For
3D
a
printing
residential
metal.
scale.
No,
But
no,
if
no,
you're
that's
talking
not
about
true.
industrial,
That's not true.
you need to
They're
talk
already
about
3D
industrial.
printing. They are 3D printing metal.
I meant
There's
for
now a
us.
printer
Yeah.
out.
I meant like here.
Oh,
Like,
you mean residential?
Oh,
yeah,
okay.
like
okay.
in a
So
home
industrial
setting.
wise, we are 3D printing alloy parts and things, and there's partially 3D printed car parts and stuff like that. Like people are doing it. Like industrial scale 3D printing alloys is happening.
Right. Right. No, that's awesome. That's awesome.
Yeah. I forgot what you were saying, Rocky. You were bringing
don't
something up
remember.
pretty interesting, and I was like ready to get into that. I don't remember what you were saying.
It was something about the guns and the 3D printed guns. What I think what I was
said,
talking
I was
about.
bringing up the resin, and I was wondering if like anybody had done a resin one yet, because we were talking about the level of detail required to print these parts, and that is why most of them fail after like 2 or 3 shots being fired. Is that the parts aren't like as precise as they need to be. If you use
they're not
resin,
as
I
precise and they're
wonder-
just not as durable. But on the
Yeah.
the level of the I would just say the error, the margin of error, right? When you get to a certain percentage, then everything in manufacturing has a margin of error, right? Just some things have a margin of error of 2 nanometers, and some things have a margin of error of 2 meters, right?
Right.
Like.
But that
it just
depends on what
depends.
you're making.
But with
right?
firearms, right, it has to be very precise. So as these filaments become smaller, and as the processes become quicker, and as the materials become
the filaments
stronger,
might remain the same size, but what you want to do is make sure that it's cooling at a smaller rate, like so that you don't see those print lines and stuff like that. Like for
That is
example, I
true.
think resin. That's why I keep saying resin is because resin doesn't have those layers that it's printing on top of. It dips into a liquid and it uses a 4K or 8K screen, and it will use that screen to melt layers or heat up layers, like cook the resin, and you have multiple layers just being cooked, so it comes out without all of those printing layers and stuff like that, and it's much more detailed than a normal 3D printer.
wow, that is crazy. I didn't even realize that. So it like takes like basically an 8K screen,
Yes.
and it uses that, I'm assuming, for like mapping, right? Mapping
It does.
exactly
And
where it needs to go.
the more
So-
detailed the screen, the more pixels you have in the screen, the more detailed the print.
Right. So,
Yeah.
and that's what I'm thinking. Like, you could really have, that's a pretty high level of precision. I'm not going to lie.
It is.
For
It's
a
impressive.
medium sized piece, right? Now, if you're
Yeah.
designing, like, say, a circular washer that is like, this like that big, then you might want to do something a little bit different. But that's really, really cool.
It's
You
really
could get
cool.
a pretty decent. You could get a pretty large piece done with a very high level of accuracy.
That's
So-
right. Yes. And they come
Yeah.
out amazing. They come
Oh,
out
yeah.
looking really good. So I'm wondering, I wonder if anybody's gotten like a 16. I don't know if they have the 16K ones out, but I know they have 8K ones out, where you can just get those for like $400. The resin printer 8K, $400, and I bet you can get like gun parts 3D printed with that are much better.
Oh, I'm
Probably
sure. There's
still,
an entire,
not at the scale they need to be, but much better than what they've been using, I'm sure.
I mean, at this point, we're already to an entire online community that shares nothing but how to make guns, right? How to 3D print guns, and that's an
That's right.
entire
There's a
online
whole
community.
community behind this. Yeah.
Yeah. Now, there is a question about how many of these guns are out there.
We have
And
no
not
way
to get
of
on the
knowing.
political side, we have no way
Yeah.
of knowing. But the investment
dangerous.
required and the trial and error required to be able to create these guns, I don't worry about it from the hobbyist perspective. I worry about it more from like a mass, production perspective. Personally,
I agree.
that's what I
Yeah.
worry about, because it takes capital up front, and you're doing it as a risk, right? People who are doing this individually, it's purely something for hobby.
Right.
Right.
I'm worried about
As
those
easy
people.
as it is to get a gun today in America, you're not going to go 3D print a gun. You're just going to go buy a
Right.
gun.
You're going to
right?
go buy
Like-
a gun because it's going to be better as well. It's going to be more
Right,
reliable, and you're not going to
Exactly.
try to use that for defense because that could
The
hurt.
only-
Like it could backfire. It was the worst scenario
Could
possible.
explode in your
It
hands.
could explode in your hands.
The only
And
reason why you
this-
would need a plastic one is just to get through like security or anything like
But
that.
even
to-
then, you can't
You
get
still
through
have
with the
metal
ammunition.
bullets.
You can't. Yeah, I mean,
Yeah.
that is true.
and then you still
Like,
have to have
you're not
like a
getting through
firing
secure.
pin. Yeah,
And it's not, the whole gun isn't plastic either. You have like few plastic parts.
yeah. You
and
still got
have metal
springs.
parts.
You've still got
have
yeah.
all the metal parts that you need. It's not
Right.
all plastic. The other thing is you the big worry is that this group builds out a very simple way to build a gun, and that's extremely fast, efficient, and reliable. And then that's great and everything, and they might be a good community, but somebody's going to come in with a bad community and see that, and they're going to go manufacture a bunch of guns.
Right, and that's I think the fear of people like the ATF, right, and being able to control who has access to these ghost guns, and control the danger of having unmarked weapons and potentially dangerous weapons. Like, I mean, you want to talk about like you're holding a 50-50 chance if it's your first time manufacturing a gun, right? Like, you have, well, I won't say a 50-50, but you have no idea if this thing's going to fire forwards or backwards, right? Like,
Yeah,
and so
I mean,
it's
the
dangerous
current
not
way,
just
yeah.
from a criminal aspect, but from a self-harm aspect. It's really dangerous because you're dealing with a bullet that could, blow your gun up, right? Because it's
even
not a real
worse,
gun.
it's not necessarily the bullet part, it's the gunpowder and explosive part of the bullet, right?
Right.
That's
Being able to
the-
contain
that's
that
the
force and
dangerous
being able to
part.
contain that
Yeah.
pressure inside of a plastic gun is terrifying.
The bullet might still fire forward, assuming your barrel's good. But let's say the explosion's not contained or the gases aren't released properly. It shatters your gun. And now all the pieces of your gun are moving just as fast as that bullet, if not really close to it. And it's all in your hand. That is going to tear up your hand. You're not going to have any feeling. It's going to tear up all the tendons on the front of, like, all the nerves on the front of your hand. Like, your hand's going to be fucked. Like, you're done,
Oh, yeah. Oh,
Yeah.
Easily. Yeah, no, I wouldn't wish that upon my worst enemy. Well, unless,
No.
I mean, maybe
I
if he
really
was about
wouldn't
to
worry
kill
about
me,
it.
then
Yeah.
I'd wish that upon him. But,
Yeah. Oh, yeah. I'd be like, oh, God, I hope that's 3D printed.
Yeah. 3D printed and has the biometrics on it too, right?
Yeah.
So-
Oh, goodness gracious.
It won't fire. It won't fire. Oh, green light.
Yeah.
Backfires.
Whoops.
Slide straight to the
I made
skull.
it myself.
Don't worry, if he shoots you in the bladder, we can print you another one.
That's true.
That's good to
true.
know.
I mean,
That's
like,
good to
so really
know.
quick to go back to that though. Like, I mean, imagine every hospital having a 3D printer on standby to be able to create organs for people that come in, right? I mean,
think-
like, you think about the current wait list for a critical organ. You're talking in some cases years. Whereas if we
some
perfect
cases
this,
it's not even possible.
right,
And then-
right. In some cases, it's not even possible. But my point goes back to, like, being able to 3D print a heart or 3D print a lung or 3D print any major organ that you need even if it was a week. Oh my God, right? Or even if it was a
fine.
month. Oh
You're
my
gonna be
God.
fine. They put
Yeah.
you on what's that machine, Greg? The machine that they put you on to keep you alive.
The
I can't-
ventilator?
Dialysis.
The dialysis. Thank you.
Oh.
That was my
I was
first thought.
Yeah, dialysis. They put you on dialysis, right? And then they 3D print your part, and then boom. You know what I mean?
Just new
hang
kidney.
tight for a bit.
New
yeah,
kidney.
just
Oh
hang
my
tight for a little
God,
bit,
dude.
Bring you back.
You know, I will say that there's a flip side to this, and I think that you're going to see a lot of black market 3D printed organs.
But
And-
remember what happens when you have a renewable resource. It loses value.
I agreed. And a kidney right now goes for anywhere from 25
Several
to
hundred
50.
grand. Yeah.
Yeah. And that's
It's
how much a kidney
ridiculous.
goes for.
Yeah.
Imagine how much a lung goes for. I mean, like, literally, you're talking about pieces
I
of material
would rather-
that could
I'd rather
save
that
someone's
happen.
life, and in like the most literal sense possible, you have a piece of a person manufactured that you can put into someone.
I would rather a bunch of organs end up on the black market due to 3D printing and some of them being a little faulty than the current situation that's like in China where they're kidnapping children and shit and
Exactly.
stealing their organs. I would much rather the latter of that scenario.
Oh yeah, absolutely,
Yeah.
absolutely. No, I completely agree. That was bait, and I want to really ask about that, but we're out of time, so we'll have to save that one for another episode.
We will talk about that. Yes.
I felt the bait so strong on that. I was like, oh my God, I want to know more because I have no idea what you're talking about, but now I'm going to go Google it.
It's bad. Yeah, it's really bad.
China. Oh, China. The porcelain doll in the front and the pile of shit behind it. So
that's right.
All right, guys. Well, this was a fun podcast. Until next time, I'll see you guys later.
See you guys later.
Later.